Take a deep, slow breath and let the weight of your body settle entirely into the quiet warmth of your bed. As you exhale, release the day, because we are immediately leaving the bounds of Earth to drift into the deep, quiet dark of the outer solar system. Right now, in your mind's eye, you are floating approximately 1.8 billion miles, or 2.9 billion kilometers, away from the sun. Out here, the harsh glare of daytime melts away into a perpetual, peaceful twilight. At this staggering distance, the light from our home star feels vastly different. It is roughly 400 times dimmer than the bright sunlight that warms your skin on a summer afternoon on Earth. It casts long, faint, silent shadows, painting the cosmos in soft gradients of charcoal and deep indigo. Settle deeply into the profound, tranquil chill of this space. In the ambient temperature of the environment you are now drifting through is approximately 77 Kelvin. That is a frigid minus 320 degrees Fahrenheit, or minus 196 degrees Celsius. But do not feel the bite of this cold. Instead, sense its stillness. This profound chill is nature's ultimate preservative, keeping everything in a state of suspended, peaceful animation. You are wrapped in a comforting void, where the frantic movement of heat is replaced by the slow, majestic physics of the cosmos. Here, in this quiet twilight, you are surrounded by the frozen rings of Uranus. For centuries, humanity had no idea these rings even existed, gazing up at the pale blue dot of the planet without seeing its delicate halo. They were only discovered relatively recently, on March 10, 1977. And here is something remarkable about that discovery. These rings were not found by capturing the light they reflect, but by patiently observing their shadows. Astronomers watched from a specialized aircraft called the Kuiper Airborne Observatory as Uranus passed directly in front of a distant background star. They expected the star's light to simply blink out once as the planet blocked it. But instead, the starlight flickered briefly, rhythmic and precise, several times before and after the planet itself passed by. The rings were revealing themselves through a process called stellar occultation. They whispered their hidden presence to humanity by briefly, silently, interrupting the distant starlight. As you float here, observing the slow rotation of the planet, you might feel a gentle, floating disorientation, a delightful shifting of your cosmic perspective. Consider this. Uranus is tilted on its axis at an extreme angle of 97.77 degrees. It is practically rolling on its side as it makes its 84-year orbit around the Sun. Because of this dramatic tilt, the magnificent ring system circles the planet's equator, almost perfectly perpendicular to the flat plane of the solar system. You are looking at a giant planetary bullseye, spinning vertically in the velvet blackness of the void. Allow yourself to feel the weightlessness of this space, where up and down lose their meaning, replaced only by the gentle pull of gravity. Surrounding you, rotating with silent purpose, are 13 known, distinct rings. They do not form a broad, continuous, blinding sheet of ice, like the famous rings of Saturn. Instead, they are entirely unique, distinct narrow ribbons of dark material, separated by wide gaps of empty space. As you drift closer, feeling the soothing rhythm of their orbit, allow your mind to focus on the most prominent of these ribbons, known as the Epsilon ring. It is the brightest and the densest of all the rings in this system. Yet, the Epsilon ring is surprisingly, beautifully narrow. It wraps around the giant planet in a concentrated band that measures only 20 to 100 kilometers wide. If you were to gently lift this ring and lay it across the surface of the Earth, Its width would barely cover the distance between two neighboring towns. It is a precise, tightly wound thread of cosmic matter spinning flawlessly in the dark. You might naturally expect these icy rings to gleam with a bright, blinding white, but as you reach out your mind's eye to touch them, you notice their true, soothing texture and color. The rings of Uranus are incredibly dark. They possess an albedo, which is a scientific measure of surface reflectivity, of only 2 to 6%. This means they reflect almost no light at all. They are about as dark as lumps of charcoal or deep, dense soot. If you could brush your hand against one, you might imagine a porous, matte texture that absorbs almost all the faint sunlight that manages to reach it. They are stealthy, silent travelers, wrapped in a cloak of deep shadow. And unlike Saturn's rings, which are filled with clouds of microscopic powdery frost, the main rings of Uranus are incredibly sparse when it comes to fine dust. As you glide weightlessly into the heart of the Epsilon ring, you realize you are floating almost exclusively among macroscopic particles. These are substantial fragments of blackened ice and rock. They range in size from 0.2 meters to about 20 meters across. Imagine resting your hand on a chunk of dark, ancient ice the size of a bowling ball, feeling its frozen, uneven surface, and then turning your head to see a massive, blackened boulder the size of a school bus drifting silently past you. They tumble endlessly, locked in their orbital dance, making absolutely no sound in the perfect vacuum of space. You might wonder how these boulders stay so perfectly aligned within such a narrow ribbon. Why don't they drift away into the vastness of space or crash down into the atmosphere of the planet? The answer lies in the comforting, rhythmic physics of the universe. On either side of the Epsilon ring, there are two small dedicated shepherd moons. Their names are Cordelia and Ophelia. Cordelia orbits just inside the ring, while Ophelia orbits just outside it. Like gentle, invisible hands, their combined gravity continuously nudges the tumbling boulders back into place. If a chunk of soot-covered ice drifts a little too far outward into the void, the gravitational pull of Ophelia slows it down, gently dropping it back into the ring. If a boulder falls too close to the planet, Cordelia's gravity accelerates it, nudging it back outward into safety. Feel that sensation of being safely guided. Imagine the comfort of being perfectly held in a delicate, invisible gravitational balance, where the forces of nature work tirelessly to keep you exactly where you belong. Humanity finally caught a direct, close-up glimpse of this delicate balance in the year 1986. The Voyager 2 spacecraft, a lone, silent ambassador from Earth, flew through this very space after a quiet journey of nearly a decade. It became the first, and so far, the absolute only, human-made object to visit Uranus. It glided through the frigid dark, capturing the shadowy majesty of these rings with its robotic cameras, and beaming those faint, ghostly images across billions of miles of empty space back to our glowing screens on Earth. But the universe always holds more secrets, waiting patiently for us to develop the tools to look deeper. In the year 2005, peering through the pristine, unblinking lens of the Hubble Space Telescope, astronomers discovered two more rings lurking far beyond the main system. These are the outer rings, officially named the Nu and Mu rings. As your journey takes you outward, gently floating away from the charcoal-dark inner ribbons, you enter the vast domain of the outermost Mu ring. Here, the very texture of space seems to change. The Mu ring is not made of large, tumbling boulders. Instead, it is composed of microscopic dust, so fine it feels like a cosmic mist, and it possesses a distinct, breathtaking color. The Mu ring is a vibrant, ghostly blue. This azure coloration is incredibly rare for planetary rings in our solar system, sharing its hue only with Saturn's outermost E-ring. The blue color arises because these tiny mist-like particles scatter blue light much more efficiently than red light, creating a soft sapphire halo that glows faintly in the deep dark. Just inside this sapphire mist lies the new ring, which, by beautiful contrast, gives off a faint reddish tint. Imagine the view as you float peacefully between these two outer bands. You are suspended between ribbons of subtle red and ethereal blue, while looking down toward the deep gray and charcoal tones of the inner system. It is a magnificent, quiet tapestry of color, painted over eons by the slow, methodical mechanics of the solar system. Despite their sprawling majesty, there is a surprising, comforting lightness to these structures. If you were to gather up every single piece of ice, every particle of dust, and every darkened rock in the entire Uranian ring system, their total mass would only be about 10 to the 16th power kilograms. While that might sound like a massive number to a human mind, in the grand, heavy scale of astronomy, it is incredibly light. It is roughly equivalent to the mass of a single, immodest asteroid, about 15 miles across. You are floating through a pulverized world, gently spread thin over millions of miles of empty space. Drifting among these ancient-looking stones, you might sense a timeless energy, a feeling of eternity. Yet, scientifically speaking, these rings are surprisingly young. They have not been here since the fiery birth of the solar system 4.6 billion years ago. Astronomers estimate that the rings of Uranus are likely no more than 600 million years old. In cosmic terms, they are a relatively recent addition to the long, slow story of our planetary neighborhood. Where did they come from? The current scientific understanding is that these dark, soot-covered boulders are the shattered remains of a moon, or perhaps several small moons. Long ago, in the deep quiet of this space, a high-speed impact shattered a solid world. There was no sound, only the silent spreading of debris. Over millions of years, those jagged fragments spread out, colliding, grinding each other down, and eventually settling into the peaceful, orderly ribbons you see today. Out of the chaos of cosmic destruction came a profound rhythmic harmony. Let the realization of that slow transition wash over you. Time heals all chaos in the universe, turning shattered moons into beautiful, perfectly balanced rings, guided by the faithful gravity of tiny moons. Allow yourself to float here, nestled in the dark, cold perfection of physics, as we prepare to drift even deeper into the mechanics of this frozen world. Continuing our silent journey through this suspended frozen world, allow your perspective to shift back toward Earth, you looking centuries into our past. In doing so, we find the very origins of humanity's relationship with this shadowed corner of the solar system. Picture this. It is the late 18th century. In the quiet, damp garden of a home in Bath, England, an astronomer named William Herschel stands under the night sky. He is peering through a homemade telescope, carefully constructed with a 6.2-inch speculum metal mirror. On March 13, 1781, as the cool English breeze rustled the trees around him, Herschel became the first person in recorded history to officially discover a planet using a telescope. He spotted a pale cyan disk moving steadily against the distant, unmoving tapestry of background stars. 8 years later, in 1789, Herschel recorded a highly unusual note in his observation journals. He claimed to have seen a ring around this newly found world. For over 2 centuries, modern astronomers politely dismissed this specific observation. They reasoned that his primitive telescope could not possibly have gathered enough light to reveal such incredibly dark, elusive bands. It was widely accepted that human eyes had never seen the halo of Uranus before the modern era. Yet, when analyzing Herschel's original handwritten notes much later, scientists caught a highly specific detail. He described the ring he saw as having a reddish hue. As we now know from mapping the outer new ring, that specific color truly exists out here. Did a man in a quiet English garden catch a fleeting, miraculous glimpse of this faint halo over 200 years before a robotic spacecraft confirmed it? It remains one of astronomy's most poetic, lingering mysteries, a testament to human curiosity reaching into the dark. Let us observe how modern science has mapped this territory since those early nights in Bath. The architecture of the Uranian ring system is categorized into 3 distinct, highly organized groups. Right now, you are looking upon the 9 narrow main rings. Moving outward from the planet, they are cataloged with an unusual, seemingly random mix of numbers and Greek letters. Deep within the system, tracing paths closest to the planet, you find rings simply designated as 6, 5, and 4. Further out, the naming convention abruptly shifts to the Greek alphabet: alpha, beta, eta, gamma, delta, and finally the outermost main band, epsilon. This mixed nomenclature is a direct, permanent artifact of how we learned to see them. When astronomers accidentally discovered these bands in 1977 by watching a distant star flicker, they initially identified 5 distinct dips in the starlight. They assigned these 5 primary shadows the first 5 letters of the Greek alphabet. As they scrutinized the printed data charts more closely in the months that followed, tracing the delicate lines of starlight on paper, they found 3 additional fainter dips nestled closer to the planet. Needing a quick way to label them, they simply numbered them 4, 5, and 6. The history of human realization is permanently etched into the very names of these cosmic structures. Notice how not all of these ribbons follow the same structural rules. The Eta ring, for instance, exhibits a highly unusual formation. It features a dense, narrow core of large boulders that measures only about 1.5 kilometers wide. However, this tightly packed core is accompanied by a broad, optically thin outer extension that stretches nearly 5.5 kilometers out into space. It is a delicate, sweeping shelf of icy material, looking almost like an ephemeral halo, resting gently alongside a more solid foundation. What is perhaps most astonishing about all 9 of these main bands is their incredible vertical thinness. While they span tens of thousands of kilometers horizontally across the planetary system, they are estimated to be less than 150 meters thick from top to bottom. That measurement is roughly equivalent to the height of a 40-story building on Earth. If you were positioned miles away, looking at these rings perfectly edge-on, they would be so phenomenally thin that they would vanish entirely from your sight, dissolving into the blackness. Furthermore, their pathways are not perfectly circular. Most of these rings are slightly eccentric, meaning they trace gentle, elongated ellipses around the host planet. Because of this elliptical orbit, the rings themselves physically breathe, stretching and compressing in a majestic rhythm as they travel. Take the massive Epsilon ring as an example. At its periapsis, the precise point in its orbit where it sweeps closest to Uranus, gravitational forces pull the particles tightly together. This compresses the ring into a highly dense, narrow ribbon, just 20 kilometers wide. But as the material swings outward to the apoapsis, its furthest point from the planet, the ring relaxes. The gravitational grip softens, and the particles spread out, expanding the band to a width of 96 kilometers. It is a slow cosmic respiration, a physical pulsing that expands and contracts with every single revolution. Let us drift in closer and examine the precise physical makeup of these breathing bands. The particles tumbling past you are not pristine, reflective ice. They are composed of frozen water, heavily mixed with complex carbon-based organic compounds. Think of this process like the slow curing of a photograph in a dark room, where prolonged exposure to chemical light slowly deepens the shadows, permanently darkening the image. Out here, the raw materials are simple molecules like methane or carbon-rich ice. Over vast stretches of cosmic time, they are relentlessly bombarded by charged particles captured in the planet's magnetic field. This invisible radiation strips away hydrogen atoms and bonds the remaining carbon molecules together into heavy, dark polymers known to scientists as tholins. The ice is effectively baked over millennia by silent radiation, turning it into the deep, matte material that makes these rings so exceptionally stealthy. This radiation environment is exceptionally strange due to the planet's unique internal engine. The magnetic field of Uranus is tilted a staggering 59 degrees away from its axis of rotation. Furthermore, the magnetic poles are not situated at the center of the planet like they are on Earth. Instead, they are offset by roughly 1/3 of the planet's entire radius. As a result of this extreme tilt and displacement, this lopsided magnetic field wobbles wildly as Uranus spins. It sweeps through the ring system like a chaotic, invisible lighthouse beam, continuously and unevenly baking the orbiting ice into those darker shades of black. There is another invisible force constantly shaping this environment, operating quietly in the background: exospheric drag. Uranus possesses an extended upper atmosphere, a vast faint corona of hydrogen gas that reaches far out into space, physically overlapping with the innermost rings. As microscopic dust particles orbit through this hydrogen cloud, they experience an incredibly faint but remarkably persistent friction. This drag slowly robs the smallest particles of their forward momentum, causing them to gradually spiral inward until they safely disintegrate in the deeper layers of the planet's atmosphere. This process acts as a continuous cosmic broom. It actively sweeps the main rings entirely clean of fine dust on a timescale of just 1,000 to 100,000 years, a measurement that represents a mere fraction of a second in the geological lifespan of a solar system. This rapid clearing mechanism leads to a profound scientific conclusion. The fine dust we do occasionally see out here cannot possibly be ancient. It must be continuously replenished by ongoing, quiet collisions. As the larger stones tumble and bump against one another in the dark, they grind fresh powder into the void, creating new dust, even as the atmosphere steadily sweeps the old dust away. It is an endless cycle of creation and clearing, balancing perfectly in the cold vacuum. Deepest within the planet's gravitational embrace lies the Zeta Ring, a broad, diffuse, dusty band falling perilously close to the swirling cloud tops. First glimpsed in the transmitted data from the 1986 Voyager flyby, it was so incredibly faint and obscured by the planet's glare that it completely evaded human detection for another 17 years. It was not until the year 2003 that astronomers at the Keck Observatory in Hawaii finally spotted the elusive Zeta Ring again. They utilized advanced adaptive optics, mirrors that rapidly change shape to cancel out the blurring, distorting effects of Earth's own turbulent atmosphere. By removing the visual noise of our home planet, they could finally see the faintest whisper of dust circling another. More recently, our vision has expanded even further. peering beyond the limits of human eyes and into the infrared spectrum. In 2023, the James Webb Space Telescope turned its magnificent golden mirrors toward Uranus, capturing the planetary system with unprecedented, glowing clarity. Through Webb's highly sensitive infrared sensors, these cold, dark bands lit up like brilliant thermal threads against the absolute blackness of space. The imagery revealed subtle atmospheric interactions and the precise dusty glow of the Zeta Ring with unparalleled sharpness. It is a quiet reminder that the universe is always ready to show us an entirely new layer of its architecture whenever we finally learn to look in a new way. Float gently within this illuminated history, feeling the slow pulse of the rings as the silent mechanics of gravity continue their endless, perfect rotation. What's happening now is a subtle shift in our celestial vantage point. As you hover near these silent rotating bands, allow your mind to draw connections between this distant architecture and the familiar objects of your daily life. By measuring the unknown against the known, the mind finds an anchoring sense of peace. Deep within this system, you are drifting inside a very specific invisible boundary, known to physicists as the Roche limit. For Uranus, the fluid Roche limit extends outward to approximately 62,000 kilometers from the very center of the planet. Think of this boundary like an invisible protective sphere where gravity dictates the rules of creation and destruction. If a loosely bound moon wanders closer to the planet than these 62,000 kilometers, the gravitational pull on the moon's near side becomes significantly stronger than the pull on its far side. Imagine holding a piece of warm, soft taffy in your hands and slowly pulling your hands apart. The tidal forces of the planet gently but relentlessly stretch the moon until it quietly pulls apart into a trail of debris. Because these rings exist entirely within this 62,000 kilometer threshold, the material here can never pull itself together to form a new moon. The physics of the space forever hold the ice in the shape of a fragmented, tumbling river. Notice how visually dense the outermost main band, the epsilon ring, appears as you glide alongside it. Despite being composed of loose, tumbling rocks, it is incredibly opaque. In fact, astronomical measurements show that this specific ring blocks up to 80% of all background starlight that attempts to shine through it. In scientific terms, this translates to a normal optical depth ranging between 1.5 and 2.3. To picture this optical depth on Earth, imagine a heavy dark velvet theater curtain, completely drawn shut across a bright sunlit window. Only the faintest pinpricks of light manage to weave their way through the thick fabric. The epsilon ring acts as a cosmic curtain, hoarding about 2/3 of the entire mass of the Uranian ring system within its narrow, shadowy folds. Picture this. You are navigating the vast, empty corridors that separate these narrow curtains of ice. The layout is remarkably spacious. For example, the empty pitch-black void separating the alpha ring from the neighboring beta ring measures roughly 300 kilometers across. If you were to project that distance onto a map of Earth, it is roughly the equivalent of a calm, 3-hour drive down a straight highway from New York to Boston. In that entire 300-kilometer stretch of space, there is almost nothing, just the perfect frictionless vacuum cradling the rings in absolute isolation. At this very moment, the chunks of soot-colored ice surrounding you are traveling at staggering speeds. The orbital velocity of the epsilon ring clocks in at approximately 10.7 kilometers per second. If you were to translate that to a terrestrial speedometer, It equals roughly 24,000 miles per hour. That is several times faster than a speeding rifle bullet. Yet, because the scale of the planet is so unimaginably vast, and because there is no air resistance to create sound or turbulence, this hypersonic motion feels completely serene. It is like watching the hour hand on an analog clock. You know it is moving, constantly ticking forward, but to the naked eye, the motion is so smooth and continuous that time appears to stand perfectly still. Scientists discovered something deeply unusual about the sizes of the objects keeping this silent time. In a typical planetary ring system, you would expect to find a massive abundance of microscopic grains, materials the size of fine beach sand or powdered sugar. However, the inner rings of Uranus are incredibly deficient in millimeter-sized dust. Instead, the material here ranges almost entirely from the size of a golf ball to the size of a standard yellow school bus. Imagine a giant cosmic gardener using an enormous mesh sieve to sift potting soil. All the fine dirt falls away, leaving only the large polished gravel behind. That is the texture of the environment you are drifting through right now. A river of macroscopic gravel, perfectly sifted by the invisible forces of exospheric drag we explored earlier. Consider the rhythm of a standard human day on Earth. We break our lives into waking hours and sleeping hours. The rings of Uranus follow a strangely familiar schedule. The orbital periods, the exact amount of time it takes for a particle to complete one full sweeping lap around the giant planet, are surprisingly brief. For the innermost bands, a single orbit takes only about 5 hours. For the outermost main rings, it takes about 15 hours. The rocks tumbling beside you complete their massive planetary journey in the same amount of time it takes for you to complete a typical workday or a long restorative night of sleep. They circle with the steady, reliable punctuality of a pendulum. To truly understand the serenity of this place, we must measure its profound chill. In the year 2019, astronomers utilized the Atacama Large Millimeter/Submillimeter Array, a massive network of radio antennas situated in the high deserts of Chile, known as ALMA. For the very first time, ALMA was able to capture the thermal glow of these dark, elusive rings. The instruments recorded their surface temperature at precisely 77.3 Kelvin. To anchor that number in a familiar reality, think of liquid nitrogen, a substance commonly used in laboratories on Earth to freeze materials instantly. Liquid nitrogen boils into a gas at roughly 77 Kelvin. The frozen boulders surrounding you are hovering exactly at that thermal threshold. They are as cold as the most extreme industrial coolants humanity can produce, preserved perfectly in the quiet dark. And yet, the massive planet looming beside these rings is somehow even colder. The atmosphere of Uranus boasts the coldest planetary temperatures in our entire solar system, with the upper cloud layers plunging to a staggering 49 Kelvin, or minus 224 degrees Celsius. It is a profound, deep freeze environment. The rings are actually slightly warmer than the planet they orbit, gently absorbing whatever microscopic fractions of sunlight they can catch on their dark, carbon-baked surfaces. As you look down at the pale cyan clouds of Uranus, a featureless and calm expanse, you might wonder what it would feel like to stand there. Despite its status as an ice giant, roughly 4 times wider than Earth, the gravity here is surprisingly gentle. If you could somehow construct a floating platform right at the visible cloud tops, the gravitational pull you would experience is 8.69 meters per second squared. Comparing this to your daily life, that is exactly 89% of Earth's gravity. If you weighed 100 pounds standing in your living room, you would weigh an effortless, comfortable 89 pounds standing on the clouds of Uranus. You would feel noticeably lighter, your steps carrying a subtle, bounding buoyancy. The heavy burdens of gravity are softened in this distant realm. This gentle gravity exists because Uranus is remarkably diffuse. The overall density of the entire planet is a mere 1.27 grams per cubic centimeter, making it the second least dense planet in our solar system, just behind Saturn. To put that 1.27 grams into perspective, water on Earth has a density of 1 gram per cubic centimeter. If you were to hold a cup of tap water in one hand and a cup of the average material that makes up Uranus in the other, they would feel almost identical in weight. This massive swirling globe is barely denser than an ocean. It is a world of gas, fluid, and pressurized ice, suspended like a delicate cyan water droplet in the vacuum of space. You are floating through a masterclass in cosmic physics, where the raw numbers of velocity, mass, and temperature translate into an environment of perfect, unending tranquility. There is no urgency in a 15-hour orbit, no friction in a 24,000-mile-per-hour glide, and no harshness in a 77 Kelvin chill. Every particle, from the golf ball-sized chunks to the school bus-sized boulders, knows exactly where to be, held in the reliable embrace of the Roche limit and the steady pulling gravity of an ocean-light world. Breathe in the perfect, mathematical quiet of this space, observing the clockwork of the universe functioning with flawless grace. Observe how the slow, perfect clockwork of this distant neighborhood mirrors the broader arcs of a human life. As you float beside these darkened bands of ancient ice, reflect on the sheer scale of time passing in this corner of the solar system. A single Uranian year, the time it takes for this massive cyan globe to complete one full revolution around the sun, lasts exactly 84 Earth years. For a human being, 84 years represents an entire rich lifespan. It encompasses our childhood, our careers, our families, and our eventual twilight. Yet out here, that entire human journey amounts to just a single, quiet lap around a distant star. Permit your thoughts to rest on that profound scale, finding peace in the knowledge that your lifelong journey is cradled by these long, celestial rhythms. Because of its extreme 97.77-degree tilt, this world experiences seasons unlike any other in our planetary neighborhood. Each of its 4 seasons spans 21 Earth years. Imagine a summer where the sun never sets, shining continuously for more than 2 decades, followed by an autumn of equal length, and then a harsh, uninterrupted winter night that lasts for another 21 years. During these long solstices, the rings are fully illuminated, basking in the faint sunlight like a giant open target. What is happening now, however, is a slow march toward an entirely different seasonal phase. In December of 2007, Uranus experienced its rare equinox. During this precise alignment, the sun shone directly over the planet's equator. Because the rings encircle this exact equatorial line, they were illuminated perfectly edge-on from the perspective of the inner solar system. For a brief magical period, the normally broad bands appeared to vanish entirely from our earthly telescopes, reduced to a line so infinitely thin it became invisible. During that 2007 equinox, astronomers witnessed a completely different process than the daily orbital mechanics we explored earlier. They observed mutual eclipses, moments when the planet's moons cast long, sweeping shadows directly onto the rings and onto each other. Think of this rare celestial event like the turning of a heavy ancient page in a grand cosmic book. The shadows acted like the long hand of a grandfather clock, sweeping across the void. The next time humanity will witness this precise edge-on equinox will not be until the year 2049. Entire generations will grow, change, and transition between these quiet cosmic milestones. Deep within the outer edges of this system, tiny companions are actively participating in the creation of what you see. Take, for instance, the diminutive moon known as Mab. Mab orbits the planet at exactly 97,736 kilometers from the Uranian center. It is an incredibly small world, measuring merely 24 kilometers, or about 15 miles, in diameter. If you were to walk at a steady, leisurely pace, you could cross the entire width of Mab in just a single afternoon. Yet, this tiny moon holds a massive responsibility. It shares its orbital path with the ethereal blue Mu ring. As Mab travels, it is constantly struck by microscopic meteoroids from deep space. Because the moon's gravity is incredibly weak, these tiny impacts kick up clouds of fine dust that permanently escape Mab's surface. This constant shedding of material is the sole source of the Mu ring. Mab operates like a crumbling piece of blue chalk, endlessly drawing a faint, dusty line in the dark vacuum of space. Reflect on how Mab sacrifices tiny pieces of itself to create something beautiful and larger than its own form. In our own lives, we frequently shed old habits, past identities, and outdated beliefs. We leave traces of our former selves behind as we travel forward. Like this tiny moon, the parts of us we let go of do not disappear. They simply transform, creating a broader, more colorful halo around our present reality. Just inside Mab's orbit travels another companion, the Moon Puck. Discovered by the Voyager 2 spacecraft during its initial approach in December 1985, Puck is significantly larger, spanning roughly 162 kilometers across. It completes its journey around the planet once every 18 hours. Puck is a dark, heavily cratered sphere. Measurements show its surface possesses an albedo of just 0.11, meaning it reflects only 11% of the sunlight that touches it. While this is slightly more reflective than the pitch-black soot of the inner rings, Puck still blends seamlessly into the shadows. It is a quiet, unobtrusive neighbor, keeping its 18-hour watch over the outer boundaries. At this very moment, navigating closer to the cyan atmosphere, we can identify one of the faintest, most elusive structures of all, the Lambda Ring, where this incredibly narrow, dusty track sits precisely 50,023 kilometers from the planet's center. The Lambda Ring is so faint that it was completely missed by initial optical observations, only revealed through intense computer processing of the Voyager. 2 image archives long after the spacecraft had departed. It exists just outside the heavily clustered inner bands, acting as a delicate, barely there boundary between the crowded inner city of ice and the sprawling, empty suburbs of the outer system. It is a quiet reality that none of these rings are permanent. The elegant ribbons of ice and stone are slowly, inevitably decaying. The constant drag of the extended exosphere, combined with microscopic collisions, is gradually robbing the particles of their forward momentum. Over the next 100 million years, the material making up these rings will slowly spiral downward, eventually raining into the upper clouds of Uranus as a quiet, invisible meteor shower. There is a profound comfort to be found in this impermanence. Even the most massive, mathematically perfect structures in the universe have a lifespan. They form, they dance for eons in the dark, and eventually, they return to the planet that birthed them. When we feel overwhelmed by the permanence of our earthly worries, we can look to the fading rings of Uranus and remember that all things, no matter how grand, are temporary states of beautiful transition. Notice how that inevitable destination, the atmosphere of Uranus, radiates a uniquely calming presence. While the rings themselves are dark and monochromatic, the globe they encircle is a soothing, featureless sphere of pale aquamarine. The origin of this color is an elegant piece of atmospheric chemistry. The upper layers of the Uranian atmosphere are composed primarily of hydrogen and helium, but they contain exactly 2.3% methane gas. When the faint, distant sunlight penetrates this atmosphere, the methane molecules act as a planetary prism. Methane specifically absorbs light at the red end of the electromagnetic spectrum, wavelengths longer than 600 nanometers. The red light is swallowed entirely by the gas, leaving only the cooler, shorter wavelengths to bounce back into space. This chemical filtration creates the signature tranquil cyan blue that glows softly beneath the charcoal rings. Scientists discovered a fascinating secret hiding beneath that blue canopy. Most giant planets in our solar system possess roaring internal engines, generating vast amounts of heat from deep within their cores. Jupiter, for example, emits nearly 2.5 times the thermal energy it receives from the Sun, creating violent, swirling storms. But Uranus is remarkably peacefully quiet. Measurements indicate that it radiates a mere 1.06 times the solar energy it absorbs. Its internal heat is virtually non-existent. Because the planet generates almost no internal heat, its atmosphere is incredibly stagnant and stable. The tropopause, the atmospheric boundary layer, where the planet's weather occurs, plunges to a minimum temperature of 49 Kelvin. Without heat rising from below to churn the clouds, Uranus lacks the chaotic, raging vortexes seen on other gas giants. It is a serene, deeply chilled world. Think about the times in your own life when you feel the need to constantly project energy, to be loud, or to churn with internal fire. Uranus proves that sometimes the most magnificent presence is achieved through total calm. By possessing almost no internal heat, it maintains a quiet, unbothered equilibrium. It does not need a raging storm to command its space in the solar system. It simply exists, massive and cool, wrapped in its fragile ribbons of ice. Permit your breathing to match the slow 84-year rhythm of this quiet neighborhood. Inhale the serenity of an atmosphere that has no need to storm. Exhale the need to hold on to things permanently, embracing the slow, million-year decay of the ice. You are witnessing the universe at its most patient, where shadows take decades to shift, and where tiny, battered moons slowly paint the void with blue dust. Every movement out here is a masterstroke of slow, purposeful intention. Delve into the subtle, invisible chemistry that shapes this quiet corner of the outer solar system. Just beneath the dark, tumbling pathways of the rings, the pale blue atmosphere of Uranus holds secrets that appeal directly to our senses, even across billions of miles of empty vacuum. We can observe these secrets thanks to an incredible astronomical breakthrough. In 2018, astronomers aimed the massive 8.1-meter mirror of the Gemini North Telescope perched high atop the dormant Mauna Kea volcano in Hawaii toward this cyan globe. By using an instrument called a near-infrared integral field spectrometer, they captured the sunlight reflecting off the upper cloud decks and sliced it into a highly detailed molecular barcode. The data revealed the distinct, undeniable chemical signature of hydrogen sulfide gas. If you could miraculously remove your helmet in this environment and take a deep, surviving breath, The overwhelming scent would be that of a pungent sulfur spring or rotting eggs. Yet, the physical reality of this space alters that sensory experience entirely. Because the temperatures here hover around a frigid 49 Kelvin, that hydrogen sulfide does not exist as a noxious floating vapor. The extreme cold forces the gas to freeze solid, crystallizing into heavy, odorless ice particles deep within the cloud decks. The scent is permanently locked away, frozen into a silent, pristine suspension beneath the orbiting boulders. Guide your focus upward, away from the frozen sulfur clouds, and back into the narrow tracks of the rings themselves. The physical texture of the objects tumbling around you is fascinating to consider. We know precisely what these ancient stones feel like because of a brilliantly designed experiment executed by the Voyager 2 spacecraft during its brief 1986 flyby. As the robotic explorer slipped behind Uranus, passing into its long cold shadow, it beamed radio signals straight back toward Earth. Specifically, the spacecraft transmitted continuous waves at exactly 3.6 centimeter and 13 centimeter wavelengths. As these specific radio frequencies pierced directly through the rings, scientists back on Earth listened closely to how the signals changed. When they were searching for a phenomenon known as forward scattering, the way microscopic dust diffuses radio waves, much like a foggy windshield scatters the headlights of an oncoming car. Astoundingly, the forward scattering was practically non-existent. The radio signals passed through the main rings cleanly, clipped only by the large solid objects blocking their path. This hard scientific data proved definitively that the main rings are nearly devoid of particles smaller than a few centimeters. Imagine walking into a high-tech anechoic chamber, a specialized room lined entirely with deep, geometric wedges of acoustic foam designed to absorb all echoes. The macroscopic gravel of the Uranian rings functions much like that cosmic foam. The particles swallow and block the radio waves without scattering them, creating a strangely crisp, a deadened electromagnetic silence. If you were to reach out and glide your fingertips across the surface of one of these dark boulders, you would not encounter smooth, glassy ice. The data suggests that these chunks of tholin-baked water ice possess a surface porosity of nearly 50%. This means half of their volume is nothing but empty space, tiny microscopic pockets of vacuum trapped within the stone. The texture would feel remarkably similar to a piece of dry, airy pumice stone found near an earthly volcano. Rough, exceptionally lightweight, and highly abrasive. Move your attention now to the innermost realms of the main ring system, where the gamma and delta rings trace their elegant parallel paths. The gamma ring is incredibly sharp and defined, measuring a mere 1 to 3 kilometers in total width. Despite its extreme narrowness, it is phenomenally dense. Optical measurements reveal the gamma ring has an optical depth reaching as high as 3.3. To a beam of distant starlight, this 3-kilometer ribbon of porous ice is practically an impenetrable brick wall. When the background star famously blinked out during the 1977 occultation discovery, the light cut out in a fraction of a single second as the gamma ring passed by, proving its edges are razor sharp, dropping off instantly into the void. Just beyond gamma lies the delta ring, measuring between 3 and 7 kilometers wide. The delta ring holds a beautiful rhythmic secret hidden in its shape. It is not perfectly smooth. Instead, it ripples. The inner edge of this band displays a subtle, unvarying wave pattern. We know the exact reason for this delicate spiraling texture. Yabarn. It is the result of an invisible gravitational handshake called an orbital resonance. The delta ring shares a specific mathematical relationship with a small inner moon, named Rosalind. Rosalind orbits the planet exactly 3 times for every 5 times the particles in the delta ring complete their journey. This creates a precise 5-to-3 resonance. Every time Rosalind passes by, its tiny gravitational field tugs on the ring particles at the exact same point in their orbit. Think of a child perfectly timing their pushes on a playground swing to make it go higher. This repeated, perfectly timed gravitational nudge physically shapes the icy boulders, forcing them to bunch together and spread apart, creating a permanent, spiraling density wave that ripples endlessly through the dark like rings, expanding on a quiet pond. Then step closer to the source of these waves, into the space nestled between the main rings and the larger outer moons. Here, you will find a remarkably crowded, busy region occupied by a group of small satellites, known collectively as the Portia Group. This family consists of 9 tightly packed moons: Bianca, Cressida, Desdemona, Juliet, Portia, Rosalind, Cupid, Belinda, and Perdita. What is mathematically astounding about the Portia Group is their proximity to one another. All 9 of these moons orbit within a radial distance, spanning only about 18,000 kilometers. They are squeezed into a space so incredibly narrow that their individual gravitational fields constantly brush against one another. By running advanced computer simulations of these orbital mechanics, the astrophysicists have uncovered a profound truth about this region. It is fundamentally unstable. The Portia Group is navigating a chaotic, precarious balance. Over immense timescales, those tiny gravitational tugs add up, slowly altering the paths of the moons. It is like watching a magnificent, intricately choreographed ballroom dance, where the performers are slowly, inevitably, drifting out of step. According to precise mathematical models of this chaos, 2 specific moons, Cupid and Belinda, are destined to cross paths. Their orbits are currently drifting closer together, and scientists estimate that in exactly 10 million to 100 million years, they will gracefully, silently collide. Furthermore, the moons Cressida and Desdemona share an even more urgent timeline. Their mutual gravitational perturbations predict an impact in just 4 million years. Do not view these future collisions as terrifying explosions, but rather as the essential slow-motion recycling program of the cosmos. When Cressida and Desdemona eventually meet in the quiet vacuum of space, they will not burn or roar. The impact will simply shatter their porous, deeply chilled surfaces, fracturing the moons into billions of newly formed dark boulders. Those fresh pieces will gradually spread out along their orbital paths, guided by the soothing laws of physics, until they smooth out into completely new, pristine rings. This chaotic planetary dance perfectly explains a mystery we encountered earlier: why the current rings are only about 600 million years old. The rings you are floating through right now are simply the shattered remnants of an ancient generation of moons that fell out of mathematical step eons ago. By observing the Portia Group today, you are actually watching the very raw materials of the next generation of rings, waiting patiently for their time to bloom. Appreciate the magnificent cyclical nature of this frozen environment. Solid moons are pulverized into porous gravel. The gravel is corralled into sharp 3-kilometer bands by orbital resonances. Density waves ripple through the darkness, absorbing radio signals in their deadened, airy pockets. And eventually, over millions of years, the exospheric drag will pull that dust down into the sulfurous, deeply chilled clouds. Everything here is part of a grand, unbroken chain of transformation. Allow the rhythmic certainty of these laws, The perfect math of the 5-to-3 resonance, the calculated decay of the orbits, the reliable freeze of the atmospheric chemistry, to anchor your mind. There is no urgency in a process that takes millions of years to unfold. There is only the slow, majestic certainty of gravity, doing exactly what it was designed to do in the deep and comforting dark. Observe the methodical step-by-step journey of a single beam of light, traveling from the sun to this distant, frozen neighborhood. The pale cyan globe of Uranus sits precisely 19.2 astronomical units away from our home star. To bridge this immense gap, a photon must undergo a silent, high-speed pilgrimage. Traveling at the absolute cosmic speed limit of 299,792 kilometers per second, the light leaves the roaring surface of the sun and travels through the frictionless vacuum. It bypasses the rocky inner worlds, crosses the asteroid belt, and glides past the gas giants. This continuous, unbroken transit takes exactly 2 hours and 40 minutes to complete. By the time that light finally arrives to brush against the blackened ice of the ring system, it has aged nearly 3 hours, delivering a gentle, diluted glow to the outer dark. We can trace another beautiful, unending process unfolding right before our eyes, the rhythm of a Uranian day. The entire planet completes one full rotation on its axis every 17 hours and 14 minutes. As the globe spins sideways, it drives complex invisible weather systems through its hydrogen and helium atmosphere. High above the equator, just beneath the shadow of the rings, bands of icy clouds are swept along by powerful winds that reach speeds up to 900 kilometers per hour. What makes these winds highly unusual is the step-by-step mechanism of their flow. They move in a retrograde direction. This means the atmospheric currents physically blow in the exact opposite direction of the planet's own rotation. It is a slow, endless friction between the spinning world and the gases that blanket it, moving smoothly without a single sound echoing into space. Above these retrograde winds, the ring particles undergo their own methodical process of decay. There is a precise mechanism at work known as Poynting-Robertson drag, as the tiny porous stones in the rings absorb the faint, 2-hour-old photons from the sun. They warm up ever so slightly. The stones then slowly radiate that microscopic heat back into space. Because the particles are moving forward in their orbit, this thermal radiation acts like a remarkably faint, continuous braking system. It robs the dust of its orbital momentum, millimeter by millimeter, causing the materials to spiral inward over thousands of centuries. It is the universe executing a perfect gradual cleanup routine, slowly drawing the debris downward into the waiting atmosphere. Direct your focus now to trace the pathway of that falling dust, descending through the planet's atmospheric layers. Uranus measures an imposing 50,724 kilometers in equatorial diameter. As we journey beneath the cloud tops, we observe a step-by-step transformation, governed entirely by immense pressure. The atmosphere gradually thickens, smoothly transitioning from a chilling gas into a dense, pressurized mantle. This hidden mantle is not made of rock. It is a hot, dark, supercritical fluid composed of water, ammonia, and methane. Deep within this fluid layer, approximately 7,000 kilometers below the visible cloud tops, a magnificent chemical process unfolds. Here, the internal pressure reaches an astonishing magnitude, exceeding 100,000 times the standard atmospheric pressure found at sea level on Earth. Under this crushing uniform weight, the methane molecules, which consist of one carbon atom bound to 4 hydrogen atoms, physically cannot maintain their structure. The sheer force systematically strips the hydrogen away. The liberated carbon atoms are then pressed tightly together, bonding instantly to form microscopic diamond crystals. Because diamonds are denser than the surrounding fluid, they begin to sink. Millions of microscopic diamonds slowly drift downward through the dark, ammonia-rich ocean. This fluid mantle, surprisingly, is incredibly hot, reaching temperatures of nearly 5,000 Kelvin. The diamonds fall like shimmering silent snow through a dark, searing liquid, continuously settling toward the planet's center. At the very end of this long descent lies the core of Uranus. It is a compact, silent sphere of silicate and iron-nickel rock, possessing exactly 0.55 times the mass of the entire Earth. The diamond rain gently collects over eons around this rocky center, a hidden treasure locked away by mathematics and gravity. Bring your awareness away from the frozen rings, away from the diamond rain, and trace the long path back toward the center of your own existence. In the physical processes shaping this distant planet are intimately connected to the step-by-step creation of your own body. The very carbon atoms bonding together to form diamonds deep within Uranus, and the carbon-heavy tholins painting the rings black, are the exact same material that builds your cells. The human body is composed of exactly 18.5% carbon by mass. You share a fundamental, undeniable chemistry with the darkness of the outer solar system. Permit your mind to recognize the origins of the elements within you. The iron that binds oxygen to the hemoglobin in your bloodstream was not created on Earth. It was forged step by step in the dying cores of ancient supernovas, dispersed across the galaxy in silent, expanding nebulas. The calcium that grants structure and strength to your bones was synthesized through a process called helium capture, occurring deep inside massive stars, millions of years before our solar system even formed. You are not simply an observer of the cosmos. You are the cosmos itself, folded into a temporary breathing form. Observe the method by which your biological systems naturally mirror the slow, reliable clockwork of planetary orbits. As you rest in the quiet sanctuary of your bed, your lungs engage in a continuous rhythmic exchange. With every standard resting breath, your body inhales and exhales precisely 500 milliliters of air, a measurement known in biology as your tidal volume. It is a steady, oceanic ebb and flow, repeating without conscious effort, just as the rings circle their planet without hesitation. Inside your skull, the complex, brilliant machinery of your mind is gracefully powering down. Throughout the day, an active human brain operates on an electrical output of roughly 20 watts of power. Now, that energy slowly diminishes. The rapid beta waves of daily thought systematically lengthen into the slow rolling delta waves of deep, restorative sleep. Your internal engine cools, reflecting the deep, peaceful chill of the 49 Kelvin clouds we left behind. Even your heart follows a methodical deceleration. A resting human heart beats between 60 and 100 times per minute. As gravity holds you safely against your mattress, that tempo drops, finding its most efficient, calmest rhythm. Your body is executing its own internal pointing Robertson drag, slowly releasing the momentum of the day, allowing your thoughts to spiral gently down into stillness. Accept this quiet transition. The universe operates on patience, and now it is your turn to simply exist. There is no task left to complete. The solar winds will continue to blow, the diamond rain will continue to fall, and the dark boulders will continue their 15-hour journeys, all without requiring your attention. You are permitted to release your grip on the waking world. Breathe in the calm certainty of physics. Exhale the tension of the day. Your muscles soften, unbinding from the skeleton forged by ancient stars. The weight of your limbs anchors you perfectly to the present moment. Your mind becomes as still and quiet as the perfect vacuum separating the gamma and delta rings. Every cell in your body knows precisely how to rest. The 20 watts of waking electricity gently fade into a soft internal twilight. The 500 milliliters of air bring fresh, quiet oxygen to every corner of your being. You are held. You are safe. You are part of the grand, unbroken machinery of the dark. Nothing is required of you until the sun rises. Your journey through the frozen outer system is complete. The comfort of the void embraces you entirely. Rest now in the endless, beautiful quiet. Good night.